Kelsey, go ahead.
5 on 117, the last two on A and B. So the answers that I got can't happen according to the domain.
So then cross them off.
That means they're not included in it.
Okay.
Okay, how did you see?
Same thing. Do exactly what you did above. So now you have theta subtract 4 pi. So 5 pi over 6 subtract 4 pi.
Or you just do it with the same one?
Yep.
Yeah. Which I have to figure out different ones.
Well, you may have to add 8 pi. Maybe that takes you, what would that be, 48? So that'd be 36. No, that'd be too much. So yeah, you'd use the same ones. Yeah. Okay, that's another thing. Getting used to using fractions again, because you can't do this on your calculator. It has to be done on fractions. So like for instance, when I have theta minus, so that's 5 pi over 6 minus 4 pi. We have to be able to do that without the calculator. Okay, so I have 5 pi over 6 minus what? How do I get that to a common denominator?
That's
4 pi over 6.
That's right. So that gives you minus 19 pi over 6, right? And your domain is between minus 12 pi over 6 and 36 pi over 6, right? So that doesn't fit in your domain, so you cross that out. Okay? Is there other questions other than that one, Kelsey?
No.
Anybody else?
7B on 118.
That's good, put a crosswalk too. Ferris wheel diameter 198 meters makes a revolution. 1 revolution in 20 minutes. What is its angular velocity in radians per minute? What is the linear velocity?
Yeah, it's just the radians per minute.
Well, revolutions per minute. So that's 2 pi radians in 1 minute, right? That's how much it goes. Like that?
Yeah.
Well, actually, it's not. If it's 1 revolution in 20 minutes, then you're doing 1/20th of 2 pi in a minute. So
So I gotta find the RPM and then I go to the other one.
yeah. So there might be is there any equation that went with this? Yeah, you just find out your RPMs for that one. I don't think I'm not too really worried about that question. Oh yeah. So you're going to use angular velocity. So velocity would be distance over time. Your distance would be your circumference over time. So how much circumference you have. So 2 pi r over 20 minutes. 2 pi times 1 half of 198, so it'd be 99, right? That'd be your circumference. So the angular velocity is circumference divided by time. Okay? And then you can change it to radians per minute after that, once you have that. Alright? Okay.
Can I be doing all these questions with my calculator in radians? Does that matter? Like, when do you have to switch it back?
Well, take a look on 4.3. Page 132. A, you're using radians. B, you're using degrees. So in B, you'd have to switch it back to degrees because you're going to need your calculator. In A, you can do it without a calculator because secant of root 2 is the same as cos of 1 over root 2, which is the cosine root 2/2, but you know those angles from your unit circle. But the second one, you're gonna have to punch into your calculator, so therefore you're gonna need to change it to degrees.
Okay, but like the ones that you're doing in 4.1, but it's just,
I don't know. how
it
many-
didn't matter. It was just like changing them from.
Yeah.
It doesn't matter
No.
though?
Not unless you went sine of an angle or cos of an angle.
Okay.
Wait, so are we just gonna instantly learn when to use radians or degrees, or are you gonna write it on the test and use
What-
the radians in this question?
Look at that question I just showed you on page 132. You see it? What's the domain in A?
It's in radians.
What's the domain in A? Well,
Gives it to you.
Oh, right, I was looking at here, okay, never mind, I was looking at the wrong one. It says root -2 in the domain, 0 is less than or equal to the angle, which is less than 4 pi.
so that's radians.
Okay.
What about B?
So if it says degrees right in the question,
Yes.
switch to degrees.
Yes.
Radians in the question is radians.
Yes.
There'll be no question where you have to use both?
No.
Okay.
Okay, makes sense? That's right, I wrote that on the board yesterday. Okay. If you, they'll give you a domain, one will be in radians, you have to solve radians. One will be in degrees, you have to solve in degrees. Okay.
You said when we asked for general form, that was radians, right?
General form and for the element of all real numbers is always in radians, yes. Okay? Good. Alright. Okay, you need to have 4.2 done for tomorrow. Those are applied. I'll give you the applied test back.
The applied ones from today?
done for tomorrow at 4.3?
Yes,
Oh, I
4.2.
didn't mark it.
4.3 is already done.
Oh boy.
That's like 7, 8.
You can totally just go. Maybe.
No, I was thinking that it's just over 50. And it's almost 40. It's like 80%.
Oh, which video did I have from this morning?
Maybe not a big of tax. Almost 50.
So it's not applied, so no.
I'm not even planning.
Give me your incentives.
That doesn't matter. Yeah, you just gotta sign this back all the time.
You got maybe?
Hey, remember a while ago how you did the passwords for like applied challenge? I lost those passwords, so you happen to have them on hand.
Not on hand. I will in about 10 minutes. Sorry, I have to, I'm putting the videos on right now, so I'll need to pull them up.
Because they both are, that's what's really different, I think, I don't know.
Hours
They both are, I figured it out.
where we get passwords and stuff to log in.
Dang.
I don't,
Let's hear the I don't know, I mean, I got two.
2 points.
Yeah, I got two. I have both. But I don't know which one.
Did you get these?
Yeah, you're supposed to say it goes.
6, 7, 8, 9. Yeah, I got 9. So. Which one's, no. Pick the same ones as me. I guess so. There was no logic there. Look at level of number.
Yeah.
What, on here?
Yeah, first thing.
Don't think about